Okay, so I'm going to turn it on in 3, 2, 1. Very nice. This is a 100 watt, 30 volt COB LED. I will be using this step-down module rated for 500 watts to step this power down from 30 volts to 12 volts, so I can demonstrate both of these COB LEDs without having to change the power supply voltage. So we are going to set the power supply voltage to 30 volts and then use a screwdriver to adjust the voltage output to 12.25 volts, because the 50 watt one, while it is rated for 12 volts, it actually only consumes about half of its rated wattage at 12.0 volts. If you want to actually have it draw the 50 watts that it's rated for, you need to give it 12.250 volts. And as for the 100 watt LED, while in the product description it says it's rated for 24 to 38 volts, in reality, when you give it anything above 30.25 volts, it will actually go over its rated wattage. So giving it 30.25 volts, it draws about 3.3 amps, producing about 10,000 lumens of light. And the 50 watt one is around 5,200 lumens. And this 100 watt one is actually so bright that it is several times brighter than all of the lighting I have here. And one neat thing about these is they seem to have like a gel, like a silicone type, like a gel type material here. It's not solid plastic. And then for the color temperature, it is 6,000 to 6,500 Kelvin. So I'm going to demonstrate the 50 watt one first, just to show you how bright that one is at 5,000 lumens. I have some 12 gauge silicone wire rated for up to 200 degrees Celsius. We are going to be cutting and connecting these to Wago connectors, which will be able to handle the power requirement for the 30 watt LED. However, because it is only a 50 watt one, because we're going to be stepping the power down for the 50 watt one down to 12 volts from 30 volts, putting it into the step down and then putting it into the Wago connectors, I am going to use thinner speaker wires for actually going into the Wago connector. This is not something that you would normally do, but because it is only 50 watts and these leads aren't really, they're kind of annoying to work with, I'm going to use a little bit of a thinner wire. And the only reason we are using such a massive step-down module here is simply to keep the heat down. Driving any module at 100% of its rated current or power will always cause it to get quite warm. So by using something that's rated for 500 watts, we can only pull a fraction of its rated power, keeping the heat low. Another thing you may notice with a bad step up or step down module I have, beside this one that I just got, is that this one has 2 potentiometers, while the new one only has 1. And there is a very good reason for that. When they put a second potentiometer on here, the second one, as you can see, is for constant current. One is CV and the other one is labeled CC, one for constant current, one for constant voltage, while this module only has 1 potentiometer for constant voltage. And I think this is better. And the reason is that the documentation for these products isn't really too detailed, and the constant current potentiometer really just makes things really difficult because it's not like it has a display or anything to tell you if you're at 100% of its allowed current or whatever. So it makes it very easy to not be able to pull the full wattage rating of this, because even when you think you're at 0, there's still a little bit of resistance there, and that's limiting your current. So I really only wanted 1 potentiometer for a voltage only, and I really don't know why they have the constant current control on here. I don't really see a purpose for that for what I am doing, but it may be something that people use. However, I have never had any good experiences working with the ones that have 2 potentiometers on them, so I just got the one with a single potentiometer, even though it was more expensive. It does come with a built-in fan controller and a fan header, which makes it more convenient because you don't need to step the power down separately for a fan. I tested this earlier in the draft takes for this video, and it works very, very well. It is very stable, and I am very happy with this device. And we already set it to 12.25 volts, even though I'm going to go over that again right now. So I actually found some 14 gauge silicone wire, which I'm going to use instead of the speaker wire I mentioned earlier, because that's technically the right way to do it. And this silicone wire is actually very, very easy to take the insulation off of. Much easier than normal wire. All you need to do is just score it. And then just use your fingernail to easily just rip it. So scoring the silicone, you don't want to go all the way through because there's very thin strands in there. So when you've got a cut, it's very, very easy to tear off. So even with cut nails, I can strip it off. And this is tinned copper. I believe it's supposed to be tinned copper. And this is 14 gauge. You can see there's barely anything there, but even that is enough to take the insulation off. So I'm going to demonstrate the brightness of the 50 watt LED followed by the 100 watt LED, and then we are going to connect it to the step down module. So first I'm going to show the brightness of the 5200 lumen 50 watt LED followed by the 10,000 lumen 100 watt LED. Then we are going to check the output voltage on the step down module and connect the Wago connectors, run the wires into the tabs, and then covering it with polyamide tape for electrical insulation that is also resistant to the heat. So first, let me show the 50 watt LED from the last video. We're going to bring the voltage all the way down from 30.25 volts down to 12 volts. 12.25 volts. It's rated for 12 volts, but here I'm going to show what happens when you give it exactly 12 volts. 12.05. And I scratched a plus symbol into here so I can remember which one is positive. So it's that one. And it is connected. So I'm going to flip this. Actually, I'm going to disconnect this. Flip this upside down. And then I'm going to touch the lead here after turning the power supply on to show you how bright it is. But first I'm going to show it upside down like this. Okay, so the power supply is now on. And I'm going to touch to the lead in 3, 2, 1. That is very bright, so I'm going to turn it upside down and show how much it can illuminate this. 3, 2, 1. So that's pretty bright, but we can do better with the 100 watt 10,000 lumen. So this is around 5,200 to 5,400 lumens of light. Quite nice, but not bright enough. And the angle on this is supposed to be 120 degrees. Now, from what I understand, you need to have a lens assembly to get that angle. However, in the description, it says the angle is 120 degrees. However, this just looks like LEDs on a plate. So I don't know if the 120 degrees is like the lens they're supposed to work with, or if they're somehow achieving that angle through this. I don't think they are. But I don't know too much about these LEDs because I've just gotten them. Let me turn that off. And you can visibly see the higher number of LEDs on the 100 watt one. So this is 50 watts, 100 watts. You can see how many more dots there are on there. Very cool. So we're going to bring the voltage all the way up from 12 volts, or actually that was on 12.05 volts, not 12.25. So that wasn't the full brightness. Of course, because I brought it down to show what happens. Let me connect this again. When you don't give it 12.25 volts. So if I connect this again, so look at that screen over there, right over here where the wattage is. Watch when I turn it on, or you can't see it. So what it says there is 38 watts. 38 watts is not 50 watts, of course. So we're going to bring this to 12.25 volts. 12.25, and now watch. Significantly brighter. So now it is drawing 48.68 watts. So that is the difference that just 0.20 volts does for a 50 watt LED. And interestingly enough, the 100 watt LED, it is rated for 30 volts DC. However, at 30 volts, it only drew around, let me test it. I don't remember. So this is the positive, which I again scratched into the tab. And the negative. The minimum voltage is 24 volts, so 24.25. So 24.05 volts, just a tiny bit over to make sure that it's actually 24 volts, because sometimes it's underrolled by a little bit. So 24 volts, which is the minimum rated voltage for this, makes it barely turn on. And let me see how many watts it's drawing. 0.55 watts, so 550 milliwatts at 24 volts. So if I was designing a flashlight and it had like a dimmer or something, 24.25 volts, realistically, let's bring it to 24.25, would be the lowest setting. So 0.25 is now drawing 0.6 watts. And watch, as I bring this up, it's going to get brighter and brighter. See? It's hurting to look at. So I'm going to look at the screen here, and we're going to bring it up to 30.25. So I'm going to turn it off. And we're going to do 28, 29, 30. Now it's on 0.35, so we're going to go down to 0.25. 30.25 is going to draw almost exactly 100 watts. Okay, so this is going to be extremely bright. 10,000 lumens, 30 volts, and 2.93 amps. This is extremely bright. Look how much brighter it is. It is going to be brighter than every light that I have over here. In 3, 2, 1. Look how bright this is. It is drawing 95, 97. It takes a little bit for it to get bright, but now it's drawing 100 watts at 30 point, can't even see the screen, it's so bright, 30.25 volts. It's getting a little bit hot. So this is an extremely bright LED. And it puts so much heat into my hands that I'm sweating now. But how about I demonstrate the step-down module? But first we are going to double check that the step-down is actually set for 12.25 volts. So connecting the step-down is as easy as undoing every screw, not completely, opening them up more than usual, just to make sure that the thick 14 gauge wires can fit in. So now I'm going to take these two Wago connectors that have 12 gauge wires already in them and connect the positive to the positive. Wago connectors are very, very useful. They have like little jaws in here that open up and clamp on the wires. Like that. And 12 gauge is the biggest wire that is supported by this. You can see it says on the side here 24 to 12 gauge. So the thinnest you can go is 24 gauge. And I'm actually going to run the 12 gauge side into the step-down module so that I can have the excess wire for the LED. So the tabs here are labeled input plus, input minus, output plus, output minus, and this potentiometer is for your voltage. So the positive input lead is first. Just gonna put it in a tiny bit. Like that. And then the negative. Making sure no strands are touching. Like that. So negative and positive is now connected. And the reason I really like these Lego connectors is because you can use them for anything from 5 volts or even like 2-3 volts all the way up to European mains voltage, 400, well, even more than that, 450 volts, 32 amps. These are very, very, very useful. So now I am going to double check the maximum input voltage for the step-down module to make sure that 30 volts is not over the limit. And it is not. This can support up to 75 volts input, so it is way below the limit. So connecting the multimeter to the output. Positive and negative is connected. So I'm going to connect the alligator clips directly to the leads here, or to the tabs, just for setting the voltage. And then once the voltage is set, I'm going to make 2 more of these Lego connectors with the silicone wire, and those are going to go to the LED. So connecting output plus, making sure it's on, and output negative. Like that. So that is set. And we are going to put negative to negative, and positive to positive, making sure there's a good amount of space between the two, and no tension that would make it want to creep towards the other one. And silicone wire is also very good for that reason too. It is very, very flexible. So even this thick 12 gauge wire can bend at very sharp angles. So I'm going to turn the power on once I have this aligned. Okay, 3, 2, 1. So it's still holding it. So it was set for 12.25 volts when given 24 volts. I set it using 24 volts. And it's only above by 0.02 volts. So this is a very good module, very stable. So we are now going to disconnect the power, wait for this to go back down to almost 0, and then we're going to start wiring. It's just basically 0 now. It's going to discharge itself over the next couple of minutes. So now I am going to get 2 more Lego connectors and strip 2 more 12 gauge and 14 gauge wires to put onto here. Or I might just do 12 gauge for the black one because I can't find my black 14 gauge wire. So I couldn't find my brand name Lego connectors, but I do have these generic ones that I got in red and blue. And these work quite well too. However, if you are doing actual wiring, like in a house or something, it's best to use the actual Lego connectors. These are more something I like to use for projects because they're very affordable, they're very cheap, and I like the fact that they can come in different colors. Sometimes I get them in white so I can paint them with Sharpies. But it comes off sometimes, so I just got the colored plastic. So I'm just going to open up 2 of these and 2 of these. Cut a little bit of 14 gauge red wire, 2 pieces. And 2 pieces of 12 gauge black wire because I can't find my 14 gauge black wire. So I'm going to strip the wires and then come back. Okay. So for the red one, we put the 14 gauge. So now it's time to plug it in. The negative one needs to open up a little bit more. And the positive, but mostly the negative. Okay, so I'm going to cut some strands off of this, minus and output, making sure nothing is shorting. Output positive. Okay. So now that negative and positive for the output are connected, the multimeter can now be attached. Again, making sure that nothing is trying to touch and make a short. Okay, positive and negative on the output are connected. I'm gonna get the power supply into view, and in 3, 2, 1, 12.27 volts, just like before. So turning that off. I'm actually going to take some speaker cable. It looks very thin compared to this, but it's not that thin. And this is speaker wire, which I've peeled one side of to get the copper one, because it has like one aluminum colored one that I can't tell if it's tinned copper or if it's like aluminum wires. So I just took the copper ones. And the reason for this is that the tabs here won't fit the 16 gauge or the 14 gauge wire. But this one, I can just put it in, fold it, and then put polyamide on the bottom. And now that I'm thinking about it, there might be some kind of proper connector for this. I'm not really sure. But for the 50 watt one, it should be enough to use these wires if we're not powering it on for too long. And polyamide tape can handle up to 230 degrees Celsius or 450 degrees Fahrenheit without melting. And it's the same type of tape you see on batteries, for example. So I am just going to put the tape here. Just like that. I'm not going to do both sides, so I can take it off after. So I'm just going to leave it like that. Or you know what, I can just close it and leave a little pull tab here. So I only need to electronically insulate one side, making sure it is insulated on the bottom, so I can put it on the heatsink. This heatsink just cooled back down. Still a little bit warm though. So we have the LED here, and the positive one is this one. So let's disconnect this, disconnect that. I'm going to take the 12 gauge ones out here. So it seems like these Wego connectors, the fake ones, are not designed for 12 gauge wire. Keep slipping out. So I'm just gonna have to cut the strands here. And then 2 more Wego connectors for the 50 watt one. So this is positive. I'm going to put polyamide tape on the other one too, just to prevent it from flickering or coming out. Like that. So we have positive and negative. I'm gonna have to be careful with this one so it doesn't touch anything. And let me get some longer wire. And I can't find my speaker wire or my silicone wire, so I am going to have to use 12 gauge. I'm gonna have to waste some more wire and cut the strands off. Or actually, I'm just gonna I really don't want to have to do this, but I don't want to have to waste a perfectly good silicone wire. So I'm just going to put some tape on there. Like that. And this is going to go into the negative. Like that. Okay, so let's test this out. I am going to connect the multimeter too, so we can monitor the output voltage of the step down. So negative and positive. So negative and positive are now connected. I'm gonna make this straight, bend that wire, like that. And when I power this on, the LED should then turn on. In 3, 2, 1, yep, so it turns on. And the input here is 30.25 volts. The output from the step down is 12.25 volts. And the step down isn't even increasing in temperature. It's a very, very efficient step down. So I don't even sense a increase in temperature. And I don't want to get the heatsink too hot, so I'm gonna go and turn it off because the 100-watt LED gets significantly hotter. Okay, so the reason I did all of this is so that now I can connect the 100-watt to the 30-volt output directly here, and then I can switch back and forth with the same output voltage. So by disconnecting the negative here and the positive there, I'm taking this heatsink. Okay, so I just checked the specifications for the power supply, and I think it may be possible to power both of these at the same time because it's a 10 amp power supply, and I have it set to 30.25 volts, and it's only drawing 3.2 or just about 3 amps on the 100-watt one at 30 volts. So that's an entire 6 amps that's available to go to that one, and that's not even drawing 6 amps. So because of how bright this is, well, actually, this is so bright that it's very difficult to even show how bright it is with the camera. So I'm going to turn the power supply on, and then I'm going to make contact with the negative lead. In 3, I'm going to do it from the bottom and not look at it directly because it is extremely bright. So making contact in 3, 2, 1. You can't even see how bright that is. So let me flip it upside down. Ready? Watch how bright this is. In 3, 2, 1. Let me put it overhead. In 3, 2, 1. Now that is very, very bright. That is brighter than the entire, and it's getting kind of hot. That is brighter than the entire lighting I have here. This heatsink is, I can feel the heat going through it now. It's a very, very hot LED. Oh, shocked me. Of course it did. It's 30 volts. Okay. So I'm not going to touch that anymore. My hands were sweaty, so it was able to shock me. Because sweat makes your hands more conductive. Okay. In 3, 2, 1. Look how bright that is. Can't even see the screen. So it's drawing 3.1, 3.2 amps now. 3.25. It's hovering at 3.4 now. And that's because it's getting hot, I think. Because this lead is pushing off of here, so I can't really make proper thermal contact. However, I think this is the one where I'm gonna have to put some thermal paste. So I'm going to connect leads in parallel. Using the discharge tester leads. So 2 negatives, 30 volts, and 2 positives. I'm just going to use the multimeter leads here. Not the thin black one for the negative because that's too thin. I'm going to use that one instead. Not that one, this one. So negative number 2. And positive number 2. So now there is 2 positives at 30 volts and 2 negatives at 30 volts. And of course it is off. So one of the positives is going to go to this step down, which is going to go into there. We're going to put the LEDs here. So this is going to be making a total of over 15,000 lumens of light. Just tensioning the wire or bending the wires to make sure there's no tension in it. And the negative goes to this one. And then the other negative goes to this one. And then the positive goes to that one. Okay, so I'm trying to keep both of these on here at the same time. Mainly the 100-watt one. The 50-watt one has a little bit of time before it heats up. So I'll have time to push down on it. And making sure that negative there isn't, the positive there isn't touching the heatsink. Okay, so when I turn the power on now, if I get that screen in frame, when I turn the power on, 30 volts is going to go directly into the 100-watt. And 30 volts, well 30.25, is going to go into the step down to 12.27 volts and sent into the 50-watt one. The 50-watt LED is generating 5,200 lumens, and the 100-watt one is over 10,000. So again, mainly pushing down on the 100-watt one, and with one finger on the 50-watt, I'm going to turn it on and then put my other finger on it. Okay. In 3, 2, 1. Whoa. I can't even see how many watts it's pulling. 120 watts. 125 watts. So turning it off because the 100 watts one is getting hot. I'm going to put some thermal paste. Okay, so I have this. Actually, this is really bad thermal paste, but I don't want to waste my good one. This is really bad thermal paste. 1.93 watts per meter Kelvin. And it is completely stuck on, so I'm just going to use this Arctic Silver MX4, which I have in a bag to prevent it from drying up like the other one. So this one has a thermal conductivity of, I don't know what it is right now, but I'm going to put it here. Okay, so I'm doing that. Just putting and I'm not like alcohol swabbing it on the bottom, even though I should. I'm just gonna put a tiny, oh, that was more than I wanted. Okay, let me put some on, let me put some onto there. And I'm gonna use this spatula thing, take a little bit off of there, like that. And put it on here, like that. Okay, so flipping this one. Now, with the alligator leads here, it's gonna make it come off. So I'm gonna take the lead off. I've ordered a heatsink that is made for these, that comes with a lens, a 120-degree lens. By degree, I don't mean the temperature, I mean the angle that's gonna make the beam go in. So that's pretty flat against there. And then for the 50 watt one, It can go into a thin film. Nice. Okay. And positive, and I forgot to offset that one. So we have our positive. And I only have 10% battery left with the phone that I'm recording with, so I need to be quick. Not quick, but need to start wrapping it up soon. Okay. So thermal paste here, and okay. In 3, 2, 1. Oh my god, I looked at it directly. Now I can't see the current. I can see 30.25. Okay, I can see it now. It's 3.4 amps. So it's drawing 4 amps at 30.25 volts, and the 100 watt one is getting quite hot. See how hot it gets if I don't touch the 50 watt one. So this is 15,000 lumens. This is so bright right now. Oh my god. Okay, let's turn that off. So it was drawing 4.16 amps at 30.25 volts. I'm going to multiply that right now and see how many watts that was. That is 125.8 watts. Not watts equivalent. Actual watts power draw for these LEDs. That is a lot of power. Whoa. So I wonder why this one looks a little bit different on the camera. Let me connect the voltmeter to the output. And I can't see properly now. This is a pretty nice heatsink too. It's handling that heat pretty well. Yeah, that's all it needs is a fan. Okay, positive is connected and negative is connected. Making sure the thermal paste isn't coming off, or the LED isn't coming off. Turning it on in 3, 2, 1. Okay, it's doing 12.25 volts. You can't see that. Wow, that is so bright that... The 100 watt one is very, very bright. My finger is getting sweaty. 4.38 amps. And for example, this is where I would put a step down. So this is a step up. A smaller little 75 watt step down for a 12 volt fan. Okay, so I've got a 6038 fan here, the same one from the hand dryer. It's another one. And I just realized I can connect that directly to the 12 volt output on here. So I could disconnect the second 50 watt or the 50 watt COB and plug in the fan instead. And I can't find any of my wires except for these breadboard connectors, which are too thin for the fan. But I think it's going to be fine for a very short amount of time. So I can't find both my speaker wire and my silicone wire, the 14 gauge. So I am going to, and what am I doing? So I am going to have to use too thin of a wire for this fan. And then these are going to go into the Wego connectors. Okay, so positive and negative of the fan are plugged into the Wego connectors. And since the wires are on opposite sides, I don't really think I need to insulate these right now because the battery on my phone is at 4%. Okay, so this is gonna have to be quick. I'm going to hold it up and I'm going to turn it on, and when I turn it on, the fan should turn on at full blast. It's going to be kind of loud, so if you have a headphone, do be aware. And the 50-watt light should also turn on in 3, 2, 1. These Wago connectors are making me so angry. So the reason it didn't turn on is not because I did anything wrong, but because these Wago connectors, the fake ones, are not made for 12 gauge wires. This is getting very, very annoying. I'm gonna have to completely restrip the wire. 4% left on my phone. 3%. I'm gonna have to make this quick. And now the wire came out of the negative and I have 1% left on the phone, or 2%. Oh my God. All because of a stupid Wago connector. And again, not the brand name ones, the fake ones. So I shouldn't even call them Wago connectors if I'm referring to those, but let's see if this works. 3, 2, 1. Yes, light is on, fan is on. Fan is backwards. It's blowing the air on my finger. 3, 2, 1. Let's connect the 100 watt. Okay, so I'm going to turn it on in 3, 2, 1. Very nice. Okay, so I'm going to have to end the video right here because, let me see, I still have 3% on the phone. I can do it one more time. So we have the 100 watts plugged in here, 50 watts coming from the step down. Step down is also going into the 6038 fan. Making sure that's not shorting. 3, 2, 1. 15,000 lumens of light. And in total, all of this is drawing 142 watts. So that light is getting a little bit hot. I'm going to disconnect it and just tap the 50 watt one. And the fan can also be slowed down using a step down module in L1 to step it down to a lower voltage. As long as it's 7.5 or 8 volts, it does start spinning at a slower speed. So this is going to be the end of the video here. So if you like the video, please like the video. And if you want to see more videos like this, remember to subscribe to the channel. And thank you very much for watching.